the previous video, we started to look at the mole concept, and because the mole is a specific quantity, basically for this topic we want to know how many particles or how much substance is present. Let's recap some of the units we met before. The unit for mass is gram, and we can find the number of moles if we're given the mass of a substance. So if we see a number followed by a G for gram, we know that we'll be using the formula mole is equal to the given mass divided by the molar mass. You should also remember that whenever we see the words molecules or atoms, we're still referring to particles. And once we are asked to find the number of particles or to find the number of moles from particles, we would use the statement which says 1 mole contains 6 times 10 to the 23 particles. Then we'll write a second statement, cross multiply, and we'll solve for x. And the unit which we'll be working with today is dm cubed, decimeter cubed, which represents volume. Should also be aware that a liter is the same as a dm cube. Should also be aware that liter is the same as a dm cube, and milliliter is equal to centimeters cubed. So these units could be used interchangeably. Don't be confused if you say liter, it's the same thing as our unit for volume, which is dm cubed. There are 4 things which describe the behavior of gases. The first is the pressure of the gas, and we discussed this under Boyle's law for those who do physics. Next is the temperature of a gas, which is discussed in Charles' law. The volume and the number of particles also determine the behavior of a gas. Now for this topic, we'll be looking at Avogadro's law, and this relates the number of particles to the volume of a substance. The number of particles is directly proportional to the volume of a substance. If, for example, we inflated a balloon, once we blow into the balloon, the number of particles increase. We're adding more air particles to the balloon, which is why the volume of the balloon would increase. Avogadro's law states that equal volumes of gases at the same temperature and pressure contains the same number of particles. This means that if we keep the temperature and pressure constant, a certain volume of any gas will always contain the same number of particles. This would be true for every single gas. It doesn't matter how small or how large the gas particles are, because we know that gases have large spaces between them. So at any given time, there's always more space than we actually have particles. It doesn't matter which particle it is, set volume will always have the same number of particles. Gases are compressible, which means we can always force the particles closer together. If we do that, the pressure would change and the volume would decrease. Because the volume can change if we change the pressure, we'll have to use a standard temperature. Because a change in pressure and the temperature will affect the volume of a substance, for these calculations, we have to use a particular temperature and pressure, and we could use a standard temperature and pressure. This is when the pressure is 1 atmosphere and the temperature is 0 degrees Celsius. And at STP, or standard temperature and pressure, 1 mole occupies 22.4 dm cubed. We could also do our calculations at room temperature and pressure, RTP, where again the pressure is 1 atmosphere, but the temperature is 25 degrees Celsius. At RTP, 1 mole occupies 24 decimeters cubed. Let's look at our first example. What volume of oxygen gas is present in 5.4 moles of oxygen at STP? The very first thing that we would need to do is to write our statement, which says 1 mole occupies 22.4 dm cubed at STP. How we would solve this is similar to when we're finding the number of particles, where we put in the information that we have and we use x as our unknown. So in this case, we want to find the volume and we're given the number of moles. So our second statement would say 5.4 mole occupies x at STP. Then we'd cross multiply, and this would say 5.4 times 22.4 is equal to x. We would simply enter this into our calculators and we would get x is equal to 120.96 units dm cubed. Our second example says, what volume of hydrogen gas is present in 0.9 moles of hydrogen at RTP? Again, we would start by writing our statement, and because it's at RTP, this time it would say 1 mole occupies 24 dm cubed. We would again write the information that we have, use an x for our unknown, cross multiply to solve. We have 0.9 moles, and this occupies x at RTP. We cross multiply. This would read 0.9 times 24 is equal to x. Input that in our calculators, and we would get x is equal to 21.6 dm cubed. For this example, we should find a number of moles of water vapor that are present in 750 centimeters cubed at STP. The first thing to note is that the units given for volume is centimeter cubed. Our statement, however, will give us the unit dm cubed. So first we'll have to convert 750 centimeters cubed to dm cubed. 1 dm cubed is equal to 1,000 centimeters cubed. So in order to convert from centimeter cubed to dm cubed, we have to divide by 1,000. Once we have converted the figure, we can go ahead and do our calculations. We'll start by writing the statement. 1 mole occupies 22.4 dm cubed at STP. Now we need to find the number of moles. So moles would be our unknown. So we'll write x occupies 0.75 dm cubed at STP. We cross multiply, and this would read x times 22.4 is equal to 0.75. We'll solve for x by dividing both sides by 22.4, and that would give us x is equal to 0.75 divided by 22.4. We would input that in our calculators. and our answer would be 0.03 moles. Remember, we're finding moles in this case, so our unit must be moles. That is it for those calculations. We have to first identify if it's at STP or RTP, and would write our first statement using the appropriate volume. 22.4 at STP and 24 dm cubed at RTP. Let's say a question asks us to find the number of water vapor particles present in 750 centimeters cubed at STP. I already know that 750 centimeters cubed is equal to 0.75 dm cubed. Well, I already know our statement says that 1 mole occupies 22.4 dm cubed at STP. Now, we could solve and find the number of moles and then find the number of particles, but we could simplify. We know that 1 mole is equal to 6 times 10 to the 23 particles, so we could write that 6 times 10 to the 23 particles occupies 22.4 dm cubed. Again, 1 mole is the same as 6 times 10 to the 23 particles. So we could just substitute that figure from here. We would then go ahead to write our second statement. The question wants us to find the number of particles. That's our unknown, which is x, and x occupies 0.75 dm cubed. Cross multiply, and that would read x times 22.4 is equal to 6 times 10 to the 23 times 0.75. We would then solve for x by dividing both sides by 22.4. That would give us x is equal to 6 times 10 to the 23 times 0.75 divided by 22.4. Once we substitute that in our calculator, we would get 2 times 10 to the 22 particles.